Hello everyone, welcome to this lesson whereby today we're going to deal with multiplication and division of complex numbers. Let's get into it. Multiplication of complex numbers. Multiplication of complex numbers is achieved by assuming that all the quantities that all the quantities involved are real. Multiplication of complex numbers is achieved by assuming that all the quantities involved are real, and then using j squared is equals to minus 1 to simplify. For example, if you have two complex numbers a plus b j and the other one c plus d j, and you want to multiply them, you would expand them just the normal way, whereby it will be a into bracket c plus d j plus b j c plus d j. Okay, this will be ac plus adj plus cbj plus bdj squared. Okay, since we know that j squared is minus 1, this will be ac plus adj plus cdj minus bd. Because of this j squared, we all know that it is minus 1. Now put like terms together, the real parts together and the imaginary parts together. AC minus BD, AC minus BD plus AD plus CDJ. That will be it. Hence, given two complex numbers, for example 3 plus 4j and 2 minus 5j, and you are asked to find their product. This will be 3 2 minus 5j plus 4j 2 minus 5j. Okay, this will be 6, open the bracket, minus 15j plus 8j minus 20j squared. Once again, we know that j squared is minus 1, so this will simplify as 6 minus 15 plus 8 is minus 7j. Okay, minus 7j, this will be plus 20, so 20 plus 6 will be 26 minus 7j. That's it. So when you are told to find the product of two complex numbers, you just assume that all the quantities are real and expand the brackets the normal way, and then use the j squared is equal to minus 1 to simplify. Let's move on. Let us look at complex conjugate. Complex conjugate. It is achieved. It is achieved by changing the sign of the imaginary part. Sign of the imaginary part of a complex number. Complex conjugate, it is achieved by changing the sign of the imaginary part of a complex number. Hence, if you have a complex number a plus bj, then its complex conjugate will be a minus bj. Okay, and another point about complex conjugate is that when you multiply a complex number with complex conjugate, the result will always be be a real number. Okay, when you multiply a complex number with this complex conjugate, the result will always be a real number. For instance, complex number a plus bj multiplied with its complex conjugate a minus bj, this will be a minus bj plus j into bracket a minus bj, open the brackets, a squared minus abj plus abj minus bj squared. Okay, notice the j minus abj plus abj will cancel out, minus abj plus, and we are remaining with a squared minus bj squared. A squared is minus 1, so minus b times minus 1 will be plus b squared. The j disappears. Now you're remaining with a real number. Let's try out an actual complex number. If I multiply 1 plus 3j, so its complex conjugate will be 1 minus 3j. To find the complex conjugate of a complex number, you just change the sign of the imaginary part. That's all you got to do. Just change the sign of the imaginary part and you get the complex conjugate of that number. So 1 plus 3j, its complex conjugate will be 1 minus 3j. Let's multiply it. 1 minus 3j plus 3j, 1 minus 3j, open the bracket, 1 minus 3j plus 3j, open the bracket, minus 9j squared. Again, minus 3j plus 3j will cancel out, remain with 1, minus 9 times j squared, we know it's minus 1, so this will remain as plus 9. Finally, the answer is 10, and it's a real number. But if you want to get that quickly, all you got to do is you square the real part, and the coefficient of j, which is 3, and you get 1 plus 9, 10. That's a shorter way. Instead of going through all this work, you can simply just square the real part and the coefficient of j, and you'll get the same thing in a faster way. Okay, so much for complex conjugate. Let's continue now to the solutions of last lesson's exercise. It was Z1 is equal to 2j plus 3j, and Z2 is 1 minus 4j, and we are asked to find Z1, Z2. So number 1, Z1 plus Z2 plus Z2, this is equal to 2 plus 3j, 2 plus 3j plus 1 minus 4j. Okay, add the real parts and you add the imaginary parts. Plus minus 4 will be minus 4j. This will be 3 plus minus j, which will be 3 minus j. Okay, that's 1. 2, Z1 minus Z2. Z1 is 2 plus 3j minus Z2 is 1 minus 4j. Okay, subtract the real parts. 1 minus 2, and you subtract the imaginary parts. If you open the bracket, minus times minus will be positive, so this will be 3 plus 4j. So it simplifies as 1 plus 7j. Okay, on to number 3. Number 3 was Z2 minus Z1. So Z2, set Z2, 1 minus 4j minus Z1 was 2 plus 3j. Okay, subtract the real parts first. Minus 1, then the imaginary part. Minus 4, minus times positive will be negative, so this is minus 3. Okay, to reduce to minus 1 plus minus 7j, and finally we have minus 1 minus 7j. Okay, so we were asked to show this. We were asked to show this on an Argand diagram. So we sketch our Argand diagram. Sketch our Argand diagram. As usual, the vertical is the imaginary. And the horizontal is the real axis. So this will be j, 2j, 3j, 4j, 5j, 6j, and 7j. And this will be minus j, minus 2j, minus 3j, minus 4j, minus 5j, minus 6j, and minus 7j. Okay, the real part have 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, 1, 2, 3. Okay, now we plot our results. So the first z1 plus z2, the answer was 3 minus j. 3 minus j. 3 is here, minus j is here. So it will be there. 3 minus j. So this is our complex number. This is 3 minus j. Okay. Second one, the result, z1 minus z2. Answer was 1 plus 7j. 1 plus 7j. 1 is here, j is here. The other one, minus 1, minus 1, minus 7 is here, so we drop that. So this is minus 1 minus 7j, and on this other side we have 1 plus 7j. Yeah, so that's it. Those are the solutions of last lesson's problems. I hope you understood that, and thank you for staying with me. See you on part B of this lesson, whereby we're going to deal with division of complex numbers. Thank you for staying with me. This is Understanding Math.